Hey, it's Mr. Redstone, and in this video we're going to be solving some polynomial equations. Now what those are, we're going to take our binomials and the trinomials that we've been looking at, and we're going to set them equal to other values. And then we're going to find the values of the variable that make the equations true. To do that, we're going to need something called the zero product property. It states that if you have two or more factors, then multiply to give 0, then either the first factor was 0 or the second factor was 0. Seems pretty straightforward. Well, let's solve a couple of these equations now. The solution to these types of equations are called roots. As you're doing these questions, if you see instructions that say solve the equation or determine the roots, it's asking you the same thing. What value of x makes these equations true? Now in this first example, I've already got it in factored form. That makes our life very easy. We've got two factors, x minus 4 times x plus 10, and they equal 0. Well, if I'm going to use the zero product property, it states that either the first factor was 0 or the second factor was 0. Now, once I've set up these two equations, I can use my knowledge of equation solving from the beginning of the year to get the values of x. In the first case, x is going to equal 4. In the second case, x is going to equal negative 10. And these are the roots. These are the values of x that make the equation true. To check my work, if x equaled 4, this is what I would have. 4 subtract 4 times 4 plus 10 equals 0. 0 times 14 is 0, and that checks out. Now if I checked x equals negative 10, I would have negative 10 subtract 4 more times negative 10 plus 10. I get negative 14 times 0 equals 0, and they both check out. This equation has two solutions. Second example, x plus 3 times x plus 7 is 0. The zero product property states that either the first factor was 0 or the second factor was 0. X is either going to equal negative 3 or x is going to equal negative 7. I won't check my work here, but if you wanted to, all you would have to do is substitute these values in for x and see that it made both sides equal to 0. Next two examples, a little slightly more difficult. Again, it's in factored form, so either 2x minus 1 equaled 0 or x plus 5 equaled 0. In the first case, this is now a two-step equation. I'm going to add 1 to each side and then divide both sides by 2. Your first solution says x is equal to a half. Your second solution would be x equals negative 5. Again, this has two roots, x equals 1/2 or x equals negative 5. The next example has three roots. X could equal 0. Change my color. 2x plus 5 could equal 0. Or 3x minus 1 could equal 0. The first solution is already worked out for us. In the second case, I'm going to subtract 5 from each side and then divide by 2. So our second root is going to be negative 5 halves. Our final root is found by adding 1 to each side and then dividing by 3. So unlike the previous examples, this equation has three roots. three values of x that make the equation true: 0, -5/2, and 1/3. So what you're going to find now is the questions aren't in factored form. 4x squared equals -12x. First thing I want to do is get all of my terms to the left-hand side. To do that, I add 12x to both sides. I end up with 4x squared plus 12x's equals 0. Well, this thing isn't called the zero sum property, it's called the zero product property. I need this in factored form. To factor this, I'm going to take out 4x as a common factor. I'll use different colors too. Once I pull out the 4x, I'm left with x plus 3. I'm going to have two roots. The first root is found by setting 4x equal to 0, which means x is 0. My second root is found by setting x plus 3 equal to 0, or x equals -3. And those are your two roots, x equals 0 or x equals -3. In the next example, we see 3x times x plus 8 equals 7x minus 10. The left side looks factored. Unfortunately, because it's not equal to 0, we're going to have to expand it before we can actually solve this question. So we're going to distribute. We get 3x squared plus 24x's equals 7x minus 10. We've got to get all of the terms now to the left-hand side. To do that, I'm going to subtract away 7x from both sides and add 10 to both sides. I'm not going to show all of my steps there. I think you should know how to do that by this point. And now I can combine my like terms. 3x squared plus 17x's plus 10 equals 0. Now we've got it equal to 0. We have to factor it. This is a trinomial, and there are lots of ways that you can factor a trinomial. Decomposition, you could use the box method, reverse FOIL, whatever you feel comfortable using. Personally, I like decomposition. What multiplies to give 30, but adds to give 17? It's 15 and 2. You look for a common factor. You pull out a 3x, you're left with x plus 5. Common factor in the next two terms was 2. You're left with x plus 5. Your common factor between those sets of terms is x plus 5. And you're going to be left with 3x plus 2. Again, we have two factors being multiplied to equal 0. Either x plus 5 is 0, or x equals -5. Or 3x plus 2 is 0, which means x would equal -2/3. And those are your two roots. The last question we're going to do in this video is a word problem. I give you the area of a rectangle. I'm going to start by drawing a picture. The area is 60. The base is x minus 3. The height is x plus 8. We need to determine the value of x that makes this happen. All right. Area of a rectangle is base times the height. And in this case, it equals 60. Just like the last example, we have part of this in factored form. The left-hand side is factored. Unfortunately, it's not factored to equal 0. It's factored to equal 60. So we'll have to expand this, meaning we have to multiply it out. We get x squared plus 8x's minus 3x's minus 24, and that equals 60. On the left-hand side, we can combine our like terms. And then to get it equal 0, we're going to subtract 60 from each side. X squared plus 5x's minus 84 equals 0. If you can get it this far, you should be able to factor it to finish it off. You're looking for two numbers that multiply to give negative 84, but add to give 5. Looks like it would be 12 and negative 7. I've skipped a few steps there in my factoring. This isn't a factoring video, it's a solving polynomial equations video. All right, now that we have it in factored form, our answers are pretty straightforward. It's either going to be negative 12 or 7. One of these answers will make a bit more sense than the other. Yes, theoretically, if you made x equal to negative 12, the area of this rectangle would be 60. But negative dimensions don't make a whole lot of sense to me, so I'm going to cross out that solution and say that x is equal to 7. And we can check our work. 7 plus 8 is 15. 7 minus 3 is equal to 4. And sure enough, 4 times 15 does give us an area of 60. Thank you very much for watching, and I'll see you on the next video. Bye for now.